Okay, so lesson 5.3, medians and altitudes of triangles. The median of a triangle should have this vocabulary right now. It's posted in classroom, but the median of a triangle is a segment that connects a vertex to the midpoint of the opposite side, okay, in a triangle, okay? So there's three medians in a triangle. The centroid is the intersection of those medians, okay? Intersection of the medians. An altitude of a triangle is a segment that connects a vertex to the opposite side, not at the midpoint, but at a, I'm going to abbreviate, at a perpendicular, okay, at a perpendicular. The orthocenter is the intersection of the altitudes of a triangle. We'll cover both of these in these notes. So in example 1, I ask you to find something called the centroid of a triangle, which is the intersection of the medians. It's important to know that the intersection of the medians is, if I graph the triangle, I connect a vertex to the opposite midpoint. Another vertex, the opposite midpoint. We'll see where they intersect. So I'm first going to graph the triangle. 2, 1 is R, 5, 8 is S, 8, 3 is T. So R, S, T. And I apologize in advance for my crooked lines. I'm not very good at drawing straight lines with this pen. So the first thing you do to find this centroid of a triangle, and this vocabulary is very important. When I say centroid, I want you to know what I mean. When I say median, I want you to know what I mean. Find your medians. So the steps to finding those medians, I'm going to use blue to find the midpoint of RS. RS, you look at it, to go from R to S, I go from 1 to 8, which means I go up 7. Half of 7 is 3.5. So from R, I'm going to count up 1, 2, 3, and a half. So the midpoint of RS, we're going to estimate. It's going to be right there. I got that in blue. Maybe I should do it in, I don't know, yellow. Hopefully that stands out a little better. Okay? So the median would connect this midpoint to vertex T. Okay? That's a median. That's the first median. Okay? Next, I'm going to find the midpoint of ST. To go from S to T, I go from 3 up to 8, which is up 5. Half of 5, 2.5. So I go up 1, 2.5. So the midpoint would be right here. I would connect that midpoint to the opposite vertex, which is R. Okay? And then finally, to go from R to T, I go up 2. Half of 2 is 1. So I go up 1. My midpoint ends up being right here. And I'm going to connect that to the opposite vertex, which is S. So I found my 3 medians. Then the only other step is find the intersection of those medians. Find the intersection of those medians, which is this point right here. And I know I wasn't perfectly on, but it's the point 5, 4. So your answer for a question like this, I'm expecting an ordered pair as an answer. So at the bottom, I want you to work through a problem independently by pausing the video, resuming the video when you're ready to move on to check your answer, and then flipping to the back to talk about altitudes and the orthocenter of a triangle. So the centroid of this triangle, XYZ, is in point -1, +2. And I know I'm way off. I know I'm way off on my straight lines, but it is -1, 2. So finding, you only necessarily need to find two medians But finding all three really helps you nail down that point and make sure that you understand you're at the right point at that median. So, on the backside, we're going to talk about altitudes. So, a shift from medians. Medians connect a vertex to the opposite side's midpoint. An altitude is the perpendicular segment from a vertex to the opposite side of a triangle. Okay? Or to the line that contains the opposite side. And I'll talk about that in a second. So, if you look at these triangles to the right, this segment I'm tracing in yellow, that's an altitude. It connects Q to the opposite side at a perpendicular. In the other triangle is obtuse. It connects Q to a line that is perpendicular. It connects to a line that extends the other side, because this altitude going from Q cannot possibly hit the other side. I can't draw a perpendicular through side PR that also goes through Q, so I extend that side. So the orthocenter, our last center we're going to cover, is the intersection point of the altitudes of a triangle. So AF, BD, and CE meet at this orthocenter. The thing I want you to know about the orthocenter is that if you are dealing with an acute triangle, that orthocenter winds up inside the triangle. A right triangle, it ends up on the triangle. An obtuse triangle, it ends up outside the triangle. So in example 3, we're going to talk about how to find the orthocenter using slope, and then describing where that orthocenter ends up, on, inside, or outside the triangle. So like before, we're still graphing. X is -5, -1. -2, 4 is Y. Z is 3, -1. And I'm going to do my best to connect those. So, to find this orthocenter, I'm going to deal with side XY, XZ, and YZ. Okay? And it's about finding slope and finding the perpendicular slope. You're going to take that perpendicular slope, you're going to use it to draw a line through that side and the opposite vertex. So XY, the slope of XY. So the number I'm going to write next is the slope. XY, I go up 1, 2, 3, 4, 5, right 1, 2, 3. So the slope is 5/3. The perpendicular slope to that 5/3 is -3/5. Okay, so I have to create a line with a slope of -3/5 that goes through vertex Z. Okay, it has to go through vertex Z. So I'm going to start with vertex Z. And you think about the slope -3/5, it means I would go down 3, right 5. I can't possibly go down 3, right 5 to go through Z and hit XY at a perpendicular. So instead of going down 3, right 5, I'm going to go up 3, left 5 to draw my altitude. And I know I'm way off. I'm not great at drawing these, but that's my altitude, okay? I went up 3, left 5. So I'm going to use a different color for XZ. XZ has a slope of 0, which means it's horizontal, okay? So the, I should have done an equal sign up there. I should have done an arrow, sorry. So perpendicular slope to a slope of 0 is a slope that is undefined. Really, all you need to understand is that you need to draw a vertical line through the opposite vertex. Well, in this case, the opposite vertex is Y. So I'm going to draw a vertical line that goes through vertex Y. So that's my altitude through Y. All right? So that's almost all of them. I just got to do one more. YZ. I'm going to find the slope of yz. To find the slope of yz, I go down 1, 2, 3, 4, 5. Right 1, 2, 3, 4, 5. Simple enough. Down 5, right 5 is a slope of -1. The perpendicular slope to 1 is 1. And that has to pass through x. So I'm going to create a line that has a slope of 1 that passes through x. So from x, I'm going to count up 1, right 1. Up 1, right 1. Up 1, right 1. And you should see that orthocenter form. The orthocenter of this triangle, I'll write it in black, is the point -2, +2. So I understand it's a lot to remember, finding these centers, remembering if it's a perpendicular, if it's a midpoint. So organizing that stuff, that's why we made that pink sheet. It doesn't help you 100%, but at least helps you keep the names straight. So I want you to try this last guided practice on your own. Find out where that orthocenter is. Remember, perpendicular and passing through the opposite vertex. So pause the video, and then when you're ready, check your answers. We'll be able to move forward. Okay, so through all that work, you find out the orthocenter is actually point K, -3, +4. It ends up on the triangle. But it's understanding you're finding the perpendicular to a side that goes through the opposite vertex. So JK, I went through L. KL, I went through J. JL, I went through K. This point was -3, +4. It wound up on the triangle because this is a right triangle. Okay? That on, inside, or outside isn't going to be as important as finding the actual point. All right? It's finding the actual point. So, should be ready to move forward to the next thing. Be very precise with your vocabulary. Don't get careless with that because it makes a lot of these problems harder. So you're ready to move ahead.